With this video, we're going to go ahead and do two things. We're first going to review simplifying square roots, and this is a really important skill that we're going to use in this unit, in subsequent units in this class, and you'll use it quite a bit in geometry and algebra 2 as well. So it's a really important skill that you kind of nail down. And the second one is going to be to evaluate expressions with square roots. So it's kind of leading into something that we'll do later on this week. So our first target, our first goal here, simplify our square roots. This symbol is our square root symbol. Remember, we're looking to do factor trees. I want to come up with numbers that multiply to whatever is inside my radical or inside my square root. So I'm going to factor tree this. Hey, if my number ends in a 0, I know that 10 goes into it. So then I would take my calculator out and do 2,100 divided by 10. That should give you 210. Now I have to check if either one of these are prime. In fact, these two are obviously not prime. So 10 becomes 2 times 5. It does not matter what order I write that in. 210 I look at, and again it ends in a 10, or it ends in a 0. So I know 10 goes into it. 210 divided by 10 is 21. If I took my calculator and multiplied straight across, I should always get back to my number inside my square root. 2 times 5 times 10 times 21. I get that in my calculator. I hit enter, I get 2,100. Problem is, these are not all prime numbers. 2 is a prime number, 5 is prime, 10 is not. So I have to factor tree 10 into 2 times 5. 21 is not. I'll factor tree that into 3 times 7. Don't leave anything up top. I want to be able to bring down all of my factors. So I multiply all of this in my calculator. I should get back to 2,100. And if I take a look at this and I multiply 2 times 5 times 2 times 5 times 3 times 7, so I multiply all of my factors down here, hit enter, I get back to my original number. That's a way to always check that you've not missed a number or left a number hanging up on the top. Now that I have all of my prime factors, all of my prime numbers, I'm looking for pairs. A pair of 2s, a pair of 3s, a pair of 5s, a pair of 7s, something to that effect. In this case, here are 2 2s. I'll draw this line to connect them. 2 times 2 is 4, so I know I can take the square root, and I'm only going to get one of them. Anything that pairs up, I pull out in front of my square root. Here's a pair of 5s as well. One of them I need. I pull it out. The other one goes away. 3 and 7 are not paired up. I don't have 2 3s, I don't have 2 7s. If they don't have a pair, I can't pull them out. I have to keep them inside my square root. Multiply outside, multiply inside. I get 10 square root 21. That is an exact answer for a simplified square root of 2,100. You're going to do number 2 on your own here in just a second. Let's take a look at number 3. This is the same concept, except I already have a number out in front. So that means when I get down to my last few steps down here, I know that that's already a number that's going to be out here, plus whatever I pull out as my factors of 384. So when I go down to factor tree, 384, all I know off the top of my head is that it's even, so I know that it goes into 2, or 2 goes into that. 384 divided by 2, and my calculator tells me that's 192. Again, it ends in an even number. I know 2, so I do 192 divided by 2. I get 96. Oops. Getting ahead of myself here. 96 is once again even. I can factor that by 2. That's 2 times 48. See how I might wind up losing this 2? That's why I keep bringing these down every time. So I have this 2, another 2, another 2, and a 48. 2, 2, 2, 48. Now I can think of numbers that aren't 2's. 6 times 8. And I'm going to move this stuff because I'm running out of room. So I'm just going to move this down. 6 is 2 times 3. Now I'm going to take a shortcut. I know 8 is 2 times 4, but that's actually going to be 2 times 2 times 2. Bring down this 2. Bring down this 2. Bring down this 2. So I got a lot of 2's. I'm going to double check to make sure I didn't make a mistake. Remember, to do that, I use my calculator. 2 times 2 times 2 times 2, that's 4 2's, times 3 times 2 times 2 times 2. So 3 extra 2's. I hit enter. 384, that's what was in the square root, so I know I'm in good shape. Now I pull out my pairs. Here's one pair of 2's that I can pull out to here. Here's another pair of 2's. Pull that out to here. Here's another pair of 2's. Pull that out to here. 3 doesn't have a partner. 2 doesn't have a partner. They stay inside. Everything out here gets multiplied together. 2 times 2 times 2 times negative 3 gives me a negative 24. Square root of 3 times 2 is 6. So that's an example of all the different types that we've practiced yesterday. I want you to finish this front page. You can go ahead and get started now. So for number 2, we should get 6 square root 6. For number 4, we get 3 square root 11 because we had a 1/2 already that got brought down. Multiply by our pair of 2's by our pair of 3's gives me 3 on the outside. So 5 and 6 are actually our special cases. Number 5, I cannot simplify this. There is no way to do this. There is no solution. This cannot be simplified. Or I'd say that this is not a real solution. Number 6 is a special case because I don't have any pairs. This can also not be simplified. Because it does not have anything that can be pulled out. This does have a correct answer though. Square root of 210 would be my final answer. For number 5, we wouldn't just leave it as cannot be simplified though. That's true, but what we would say as our answer is that this is undefined. That would be an answer to number 5 when the negative is inside your square root. On the next side of this page, we go into actually using the square root in certain expressions and how do we evaluate an expression. The major thing that's new here is this symbol that you see in numbers 7, 8, 9, and 10. That's a really important symbol. And it means basically that that's not just one problem, this is 2 problems. That is called the plus or minus symbol. It means you are going to add and subtract these. It means you have 2 different problems. In these directions, it also states round your answers to the nearest hundredth. You will be assessed on whether you can follow directions and on whether you know how to round. The big thing here is this is not one problem. This is 2 separate problems. This is 3 plus the square root of 8 over 5, or 3 minus the square root of 8 over 5. That's your plus or minus right here, plus or minus. So you have to solve this in 2 separate steps. To do that, at this point, all you need to do is put this in your calculator. You just have to be very careful with how you do that. Since you have multiple terms in your numerator, you have to use parentheses like with other fractions, but a little bit different. I'm going to open parentheses and put 3 plus square root, which is second x squared, 8, close the parentheses twice. This first one here was because the square root opened one. If your calculator, if you have a newer version, it doesn't do that, then you're fine. You just need to close that. This is my entire numerator. Now I hit divided by 5 and enter. I get 1.165 hundredths is 2 decimal places. That means I look at the third, it tells me what to do with the second. 5, 6, 7, 8, or 9 means bump the second one up 1. 0, 1, 2, 3, or 4 means keep the second one the same. This is a 5, that means bump this up to 1.17. Or, now I have to do it with subtraction. If you don't want to type all of this in at once, here's your other option. Type in your 3 minus square root of 8. Type in your entire numerator, get an answer, hit enter. Then divide by 5. So you'd have to hit enter twice here. Get 0.034. That 4 means keep the 3 the same. It's 0.03. You have 2 answers here. One when you add, one when you subtract. Just to show you, if I had not done that in 2 steps, and I didn't have my entire numerator in parentheses, I'm going to get a different answer. This answer is incorrect. This answer is doing your division first because it doesn't have any parentheses around your subtraction problem in your numerator. So that's the incorrect answer. It's following the order of operations that you're typing, not as it's written in the fraction here. I want you to go ahead and take a couple of minutes, press pause, and try numbers 8, 9, and 10, please. Press pause, try those, and then check your answers. For number 8, we have our -4 plus square root 25 over 3 gives us 0.33. -4 minus square root of 25 over 3 gives us -3. For 9 and 10, I have gone through and listed our 2 possible problems. You have to make sure that you've done these correct and then double check your work in your calculator. So for number 9, we should get -1.21 or -0.22 when we round accurately. But number 10, I'm guessing you guys might have got stuck on a little bit. I've typed mine into the calculator already. My -1 plus square root -16 divided by 2. I have my parentheses around my numerator. Likely this is what happened to you. It says that there's an error. It's a non-real answer. That's what your calculator is telling you. And that's correct. This answer, while it mathematically can be done, the solution we would get is not real. That's an Algebra 2 concept, an Algebra 2 topic as far as a real number versus a number that's not real, or a non-real solution. You don't have to worry about that. All you need to know is, 1, this is happening because I have a negative inside my square root here. And 2, you can state that this is undefined because of that. There is no solution here, and we'll get to problems like that very shortly when we talk about solution versus no solution. For now, since this is not an equation, it's just called undefined. This last section today is about evaluating the discriminant. We'll learn more about the discriminant later on. What you need to know right now is, if I give you values for variables a, b, and c, that you can plug it into and accurately solve this expression, which means anytime I have a b, I'll square it in parentheses, replace a in parentheses, replace c in parentheses. My b is -6, a is 2, c is 14. That is not the same thing as -6 squared. You must have the parentheses. I cannot express that enough or as important as anything. You must have that negative in parentheses when you square it to get positive 36. 36 minus 4 times 2 times 14 is 112 to give you an answer of 36 minus 112. -76. Go ahead and complete 12, 13, and 14, please.